Bill and the person of technological know-how have been intriguing us with state-of-the-art discoveries and uncovering their mysteries for many years. Bill N9 has taken our hobby to the very last frontier and its enigmas as he introduces us to the vastness of space that surrounds us and stretches infinitely above us. Now, Bill N breaks the silence on the most recent photographs from the James Webb Telescope, which provide us with a glimpse into the universe more than 13 billion years ago, essentially changing our understanding of the cosmos and our perspective on life itself. This telescope is making groundbreaking discoveries about planets, remote galaxies, and much more. It is a modern scientific leap forward and a worthy successor to the Hubble Space Telescope. So, what is so unique about the JWST photos that have confounded our expectations and theories? And what does Bill N have to say about them? The development of this telescope was the result of years of work by NASA scientists and engineers, and it was launched on Christmas Day 2021. The various stages of the telescope's deployment proceeded smoothly over the following months. By the end of June 2022, scientists began to discover thousands of new galaxies, older and more distant than previously known. Some of these galaxies may have formed 150 million years before Hubble's oldest discovery. Additionally, the telescope can capture enough light from celestial objects, including exoplanets and stars, to determine their composition and trajectories through space. Bill N states that this data is already starting to reveal, in incredible detail, the atmospheric composition of planets light years away from Earth, allowing scientists to make predictions about their potential to harbor life as we know it. One of the Hubble Space Telescope's most iconic images has long been the Pillars of Creation within the Eagle Nebula. This structure was seen through the telescope, which primarily detects visible light, but the process of star formation within it was not visible. However, the Webb telescope's infrared imaging has captured these formations in detail, revealing many protostars appearing as tiny red dots against the backdrop of the pillars. These stars are still forming, and according to Bill N, they are not yet burning hydrogen. As more material is drawn to the core of each star, it becomes denser and eventually reaches the point where hydrogen fusion begins, causing a dramatic rise in temperature to about 2 million degrees Celsius. Two distinct colors in the image represent infrared wavelengths that are mostly invisible to the human eye. The only visible part of the image appears blue, while the colors enhance the red radiation in the image. Since protostars emit radiation at a wavelength 6 times longer than what the human eye can see, this image not only demonstrates the infrared capabilities of the Webb telescope but also provides insight into how stars like our Sun form. The first exoplanets were discovered in the 1990s, and today, more than 300 confirmed planets are known to orbit distant stars. However, only about 1,000 of them have been directly imaged. Most exoplanets are too far away to be seen directly and are typically detected when they pass in front of their parent star, dimming its light slightly. The first direct image of an exoplanet was taken in September of last year. This planet was first identified in 2017 and was given the name HIP 65426b. Scientists used coronagraphs on telescopes to block light from the central star, along with 2 of Webb's cameras, a series of filters, and other instruments to observe it. The planet has several characteristics that make it easier to detect. It is extremely distant from its parent star, about 100 times the distance between Earth and the Sun. It is also a massive gas giant, nearly 12 times the size of Jupiter. Although the ghost galaxy is difficult to see in the sky, its brightness can be captured effectively using an infrared camera. The spiral of the galaxy and its array of stars extending from a bright center are visible in optical images of the object, also known as M74. However, a recent image from the Webb telescope shows structures resembling filaments of warm dust and gas radiating from a luminous core, depicted in electric blue. This new image highlights star-forming regions scattered along the galaxy's spiral arms. By combining images from the Hubble and Webb space telescopes, scientists have created a stunning composite image that integrates both optical and infrared views of the galaxy. This composite was produced by researchers at the European Space Agency, ESA, as part of the PNGS project, an international initiative that utilizes Hubble, Webb, and several ground-based telescopes to study 19 nearby galaxies in infrared wavelengths. With Webb's sharp observations in the longer wavelengths, astronomers can identify star-forming regions within galaxies, measure the masses and ages of star clusters, and analyze the characteristics of tiny dust particles drifting through interstellar space. An image of a distant star called Wolf-Rayet 140, taken in July of last year, revealed an intriguing diffraction pattern, a visual artifact that appeared in the photograph. However, the star was also surrounded by a peculiar pattern of wavy, concentric rings with a slightly square shape. These rings, unlike the diffraction pattern, are features of massive Wolf-Rayet stars, which are in the late stages of their lives and have already shed a significant amount of hydrogen. The interaction between WR140 and a smaller companion star is responsible for the extraordinary shapes of these rings. The Webb telescope is designed to observe the most distant galaxies in the universe. In mid-December of last year, researchers announced that they had detected 4 of the oldest known galaxies, visible for the first time through Webb's advanced capabilities. These galaxies date back 13.4 billion years to when the universe was only 350 million years old, about 2% of its current age. These 4 galaxies were expected to be incredibly ancient, much like the hundreds of other galaxies identified by Webb. Researchers determined their ages as part of the James Webb Advanced Deep Extragalactic Survey, JADES, using data from the near-infrared spectrograph, which quickly measures the distance of galaxies. This elongation of light waves, caused by the expansion of the universe, is measured using the redshift of galaxies. The largest redshift ever recorded was 13.2. These galaxies are far more numerous than expected before the launch of Webb. For the first time, we can study protogalaxies using this telescope and spectroscopically confirm their extreme distances. Meanwhile, the Webb telescope has studied a planet orbiting a star in the constellation Virgo, conducting one of the most extensive investigations of extrasolar planets. The planet, called WASP-39b, is located 700 million light-years away and is about 8 times closer to its star than Mercury is to the Sun. This Saturn-sized gas giant is heated intensely as it orbits its star. Its atmosphere is composed of thick clouds containing sulfur and silicates, including sulfur dioxide. Scientists were able to detect carbon dioxide in its atmosphere using 2 of Webb's spectrographs. Now, let me know what you think in the comments section. If you liked the video, don't forget to